Hello, I am Luiz Ghelmandi Netto. I'll be presenting this work, which is part of my doctoral thesis, Emergy Assessment of Residential Lighting Technologies in Brazil, Functional Unit Analysis and 2030 Projections. Residential lighting accounts for 19% of electricity consumption worldwide. In Brazil, the residential sector accounts for 29% of country's total energy consumption, and of this 29%, 45% is attributed to light bulbs. Here we have the four lamp models that will be studied in this work. Incandescent lamps, which are the first type of technology used. Then came the fluorescent lamps, tubular fluorescent lamps, FFL, and compact fluorescent lamps, CFL. Today, the most advanced lamp technology is the LED lamp. It can consume up to 80% less energy than an incandescent lamp. The critical points in lamp-related studies focus predominantly on the usage phase. The production and raw material obtention phases are practically neglected. This can lead to an underestimation of the real environmental burden that this type of technology can generate. Production impacts can exceed those of use, and we will see if this is truly true later. Combining energy synthesis with the projected demand for lamps in 2030 allows us to conduct an integrated holistic assessment. This integrated holistic assessment allows us to fully understand the actual environmental loads of the system under evaluation. Furthermore, it can also support effective policies to reduce environmental impacts. In this study, we wanted to compare four main types of light bulbs: ICL, CFL, FFL, and LED. We looked at how they are used in homes across Brazil using energy synthesis to understand their full environmental impact. Our objective was to measure how environmentally friendly each type of light bulb is. We also predicted how much lighting bulbs Brazil will need in 2030 and then calculated the total environmental impact for all of it. Finally, we want to give clear information in order to help smarter choices about energy and sustainability, showing which lighting options are the more suitable from this point of view. In this work, we use the lumen hour functional unit. The lumen hour provides a fairer comparison between different lamp technologies. Because comparing only by power, lumens, and lifespan alone would be unequal, we will use the functional unit integrated with Emergy, SEG per lumen hour. For lamp demand between 2018 and 2030, we use multiple linear regression. The variables we use to determine the number of lamps in 2030 were population, GDP, and consumer households. Where did we research this data for these variables? From Equipment Ownership and Usage Habit Survey, PIP-Age, Brazilian government's official system for consulting and extracting statistical data on the country's foreign trade, Comex-Stat, Brazilian Energy Research Company, EPE, and Brazilian Institute of Geography and Statistics, IBGE. Emergy synthesis is a methodology created by Howard Thomas Odell. It is based on the premise that all goods and services on the planet originate from sunlight. It uses the unit of solar energy Joule. Here we have a diagram of all necessary input flows, both for the production of the lamps, which in this case we will call EP, energy for production, and for the use of these lamps, which we will call EU, energy for usage. We will convert all these input flows into solar energy joule using UEVs, which are the units of energy value. Then we will multiply each of these inputs by the corresponding UEVs and obtain the amount of energy required to produce and use these lamps. Now, let's explain how we projected demand for light bulbs between 2018 and 2030. First, we went to Comex Stat and obtained import data for these bulbs between 2018 and 2023. For the 4 types of bulbs analyzed here: LED, compact fluorescent, tubular fluorescent, and incandescent. From this data, we calculated an annual variation rate for each of these bulb types. This annual variation rate was integrated with data on average bulb consumption per household in Brazil from 2019 pph. After this integration, we were able to determine average number of bulbs per household between 2018 and 2023. The next step was to add the socioeconomic factors. Finally, we used multiple linear regression to determine the number of bulbs consumed per household in Brazil in 2030. We use multiple linear regression because it's more than one independent variable. Here we use 3: population, GDP, and consumer households. This table shows the technical characteristics of each type of lamp studied in this work. This data was taken from a study that performed a life cycle analysis of these 4 lamp technologies for the Indian context. We used this data in our work because we were unable to find similar studies adapted to the Brazilian context. When we looked at each lamp technology, we encountered 2 particular categories: miscellaneous and packaging. For miscellaneous components, the original authors couldn't easily separate and measure many small items like solder or glue, so they grouped them in this category. In our study, to keep things consistent across all lamp types, we decided to represent this miscellaneous category as tungsten. We chose tungsten because it's a very important material in the traditional incandescent lamps, helping us to equalize this category across all technology. As for packaging, we simply assumed that all lamp packaging was made from cardboard for our calculations. Now let's analyze the lamps individually. The incandescent lamp was the lamp that required the least amount of energy to be built, but we will see that this doesn't mean it has better environmental performance. The second smallest was the tubular fluorescent lamp. The tubular fluorescent lamp is a lamp that has the action of the components with greater distribution. The second largest was the compact fluorescent lamp. This is due to the fact that it is a lamp that is complex to be built. It has integrated electronic circuits. LED was the lamp that required the most amount of energy to be built, also due to its technological complexity. Now, let's analyze each type of lamp technology by its functional unit. So here we have the energy performance ranking. The tubular fluorescent lamp had the best performance. The LED came in second, the compact fluorescent lamp came in third, and the incandescent lamp came in fourth. Why the incandescent lamp has the worst performance? Because it's a lamp with a short lifespan and requires high power to be used. It has the greatest impact on both production and use phases. What does the LED lamp have the second best ranking? Because it has long lifespan and high efficiency. The LED lamp has the second highest energy impact on production, but has the lowest energy impact on use. The compact fluorescent and tubular fluorescent lamps have a moderate impact. The compact fluorescent lamp loses out a bit due to its construction complexity. The tubular fluorescent lamp has a long lifespan and a high number of lumens, balancing its impact and giving the best overall performance. Looking ahead to 2030, our projections show that LED lamps will dominate the market, capturing 96%. Incandescent lamps will hold a small 3%, and all fluorescent lamps combined will make up the remaining 1%. Now, is a crucial point. Even with just a 3% market share, incandescent lamps will still account for 24% of the total Emergy consumption. This highlights the severe inefficiency. Of course, LEDs will have the largest overall impact, simply due to their widespread adoption. But the real takeaway here is this: reducing the number of incandescent lamps in the market is the single most important step we can take. This reduction will be responsible for the greatest decrease in environmental impacts. Based on our analysis, LEDs are the most suitable lighting choice for Brazil residential sector, offering the best balance between their production impacts and operational efficiency. Looking at the per unit analysis, fluorescent tube lamps showed the lowest Emergy per lumen hour. LEDs demonstrated a strong balance, particularly with the lowest usage Emergy. Incandescent lamps, however, were consistently the most environmentally burdensome. It's important to note that the usage phase is the primary driver of Emergy across all technologies. Regarding the aggregate impact projected for 2030, LED market's dominance at 96% means they will account for 81% of the total Emergy demand. Meanwhile, inefficient incandescent lamps with only a 3% market share are still projected to contribute 24% of total usage Emergy. Our recommendations are to prioritize LED adoption. Concurrently, we need to focus on improving their design, manufacturing, and end-of-life management to manage their substantial aggregate Emergy demand effectively. For future research, we suggest including the disposal phase. Finally, I would like to thank you very much, and I am available for any questions you may have.